Today's video will demonstrate how to design with ISA and HAZA. Hello, I'm James Helfrich. The two main types of class relations we have are inheritance and composition, but how do you tell which to use in a given circumstance? This video will demonstrate that process. Most class relations can be classified as ISA or HAZA. Now, ISA refers to inheritance where the derived class is a specialization or a variation of the base class. You can usually tell if two classes are related by ISA when you can use that phrase to describe the relationship. For an example, a savings account is a type of account. HAZA refers to composition, where an object is a member variable of another class. And you can usually tell if two classes are related by HAZA when you use that phrase to describe them. A spaceship has a position. There are four basic options when working with class relations. Number one, neither. It is neither ISA nor HAZA. In other words, you have two sibling classes or two unrelated classes or a wide variety of situations. Of course, this is the default. The second, when only HAZA means composition or aggregation is applicable in this circumstance. And usually this means when there's more than one instance of a given class related to another class. The third is when only inheritance can work here. In other words, one class is a special type of another class. And the final is when either will work, but usually one choice is going to be better. Okay, let's take a look at an example. There are three types of contact information in an address book application: a phone number, an email address, or a street address. So let's see here. It might appear there are three types of address are independent because a phone number, an email address, and a street address are quite different. However, they are all types of contacts. So let's take a look at our Venn diagram. We have a phone number, email, and a street address, but these are all types of contacts. So, I think this is a type of contract. ISA seems to be the right one. So I'm going to make a phone number, an email, and a street address as my three individual classes. But then I'm going to make a contact as well, and this contact will be the base class. And therefore, phone number, email, and street address are related by inheritance. Now, we do have a collection of addresses in my address book. Therefore, I'm going to have an address book, which is going to have many contacts through composition. So observe that phone number, email, and street address are types of contacts. Therefore, inheritance is the best choice. But because there's more than one contact, I must use composition between that and address book entry. Let's take a look at another example. A chess program can have many types of pieces on a board: a king, a queen, a rook, etc. And each piece knows its symbol, king, queen, rook, whatever, as well as how it can move. So at first glance, the various chess pieces seem to have nothing in common. A rook and a queen really are quite different. So therefore, I'm going to have six classes: queen, rook, bishop, king, knight, and pawn. So I'm going to have six individual classes. As I start digging into this, however, I notice that these are two types of pieces: those that slide and those who do not. So we have the sliding pieces, which are the queen, rook, and bishop, and there's the non-sliding pieces like the king, the knight, and the pawn. So therefore, I'm going to have a class representing sliding pieces and a class representing non-sliding pieces. And these can be related by inheritance because the queen, the rook, and the bishop are types of sliding pieces, and the king, the knight, and the pawn are not. But now all of these different types of pieces are all, well, types of pieces. Therefore, I have a base class called a piece, and my sliding piece and my non-sliding piece will be related to them. Now observe, every piece is going to have a position. Therefore, it makes sense that sliding pieces and non-sliding pieces, as well as queen, rook, and bishop, are all going to inherit off a piece. But only the sliding pieces know about the slide and can get moves based on it. Because we cannot know which of the different types of pieces are on the chessboard, polymorphism is required. In other words, a given piece could be really a bishop, a queen, a rook, could be anything. And this yields inheritance. Each piece can be any type of variety. But there's also composition because the board itself is going to have many pieces. In fact, 64 of them if I include the space as well. Now, therefore, I must have HAZA because of composition, because I have numerosity. I have more than one piece between board and piece. But it's also best if I have inheritance to capture what's unique about the different pieces as well as what's common between them. All right, let's take a look at a final example. A velocity consists of a speed and a direction and a position. Now, the direction or speed are just scalars, but the position is a class. So for the Venn diagram, the position is going to be within the velocity. Is that going to be ISA or HAZA? Well, Because they are both related by sharing a common core, namely position, either ISA or HASA could work. Now on the left, I can say that velocity has exactly one position, or on the right, I can say that a velocity is an elaboration of a position. It's everything that a position is plus a direction plus a speed. Now, both of these will work. They'll work exactly the same. They will have exactly the same functionality. The question is, which one's better? Well, from an alignment perspective, in other words, when I talk to the subject matter expert, they're going to probably say that a velocity has a position rather than a velocity is a special type of position. Therefore, for alignment reasons, I'm going to suggest composition over inheritance. This is example 3.8.1, .2, and .3 in the ISA and HASA chapter of the Software Design textbook.